Hello, friends. Good evening. Welcome to my YouTube channel with my name Yugal Pachori or the researcher Yugal. So, as you all know, that I do post videos related to different topics, and I'm doing PhD from IIT Mandi, and this is my fourth year of PhD is about to start from School of Computing and Electrical Engineering, and at present I'm the senior research fellow in the School of Computing and Electrical Engineering, that is SKI IIT. So, as you all know, that I do post videos related to different topics and different content. So, continuing the series, like I was posting videos related to the electronic devices and circuit theory from J. L. Boylsted. That is a book that I am referring. But here, the topic of discussion is quite simple. That I am discussing about the semiconductor physics, semiconductor devices, and the first chapter of the Boylsted I have discussed. Now I will discuss the second chapter of the Boylsted, and let me share my screen with you so that you can able to get the things what I'm trying to say. So this is my screen, and as you can see that we are discussing the diode application. Diode applications means I have told you in my previous videos that what is a diode and what are the applications of the diode that we will discuss in this chapter. That is from the Boyle state. First of all, we need to understand what is diode. That we have already discussed. That diode is a two-terminal device. One is positive, other is negative, anode and the cathode. And if we applied positive bias to the diodes, it become forward bias. If we applied uh, uh, positive to the p type and to the negative to the n type, it become forward bias. And if we applied opposite, it become reverse bias. And if we do not apply any bias, it is works in the no bias condition. So these are the basic operations of the diode that everyone knows. And with my discussion, you can try to understand what is the diode. Now we will discuss the what are the applications of the diode. For the application of the diode, we need to understand first of all what is diode. That I've told you that what is a diode is that it is a two-terminal device. One is anode and other is cathode. P-type and N-type. When P-type and N-type semiconductor both are fused together, it forms a diode. Now look at this simple circuit of a diode. This is battery. E is referred to the EMF, and VD is the voltage across the diode. ID is the current through the diode, and this is the resistance. So when you apply some voltage to the diode, the current flows. If it is an on state, the current will flow. If it is an off state, the current will not flow. So diode act as a switch. This we have discussed already in the previous video. And as you can see in this graph, this is the voltage versus current graph. The current is flowing. Initially, it is zero, then it is increasing, then it is increasing very rapidly, very fast. So you can, if you have seen my previous video discussion regarding to the diode, and those who are the student of electronics can understand what this graph does mean. So according to the discussion, like you can see in this figure 2.1, there's the caption says the series diode configuration. It is a circuit and the characteristics. This is the circuit of the diode, and these are the characteristics of the diode. But and there is a Q point also. I have already discussed what is Q point. Q point is the operating point, the point between the voltage and the current. This is the voltage point, this is the current point. The current and the point that meeting the voltage and the current is known as the Q point or the operating. We will come to know the significance of the Q point in the later part of the discussion. But here, what we are trying to discuss is the configuration of the diode. See, you can see this is the resistance, this is the resistance, but this is the load resistance, and this is the resistance of the diode. So, like, if you see, yeah, this is the topic that I am trying to discuss today, the series diode configuration. The series diode configuration means when the diode is connected in series. We will, in the last section, we found that result obtained using the approximate piecewise linear diode, like we have discussed the piecewise linear diode, and the diode has a resistance, diode has a capacitance, and there is a concept of ideal diode, and there is a concept of practical diode. So these are the things that now what is our discussion is now we have the diode. Now, how we are going to connect that particular diode is our application. So, on the basis of the application, on the basis of the connection, there are various types of connection: series connection, series parallel connection, parallel series connection, parallel connection. So, there are kind of four kind of configuration that we can do with the diode. So, like you can see, this is silicon diode has a cut-in voltage of zero point 0.7, and there is a current, no current. This is current. This is current. So you can understand with these graphs, like this is the characteristics of the practical diode, and these are the characteristics of the ideal diode. So you can understand the difference between the practical and the application diode, and the practical and the ideal diode. But we are discussing the configuration of the diode. So let me give you some diagram related to that. So just give me some time. Let me search the diagram. Yeah, you can see this diode, silicon diode is connected with the resistance. So whenever you applied some voltage, there will be voltage drop across this diode, and there is some voltage drop across the resistance, which is VR. So the total voltage drop across this line will be VD plus VR. Hence, you can do the calculation of this particular circuit. So you can see the ID is equals to zero, and they are trying to solve this numerical. Likewise, if suppose a diode is off, then the VD will be, there will be no current, and it will act as a off circuit. So according to the placement of the diode, placement or the connection of the diode, your circuit will work. But the basics remains the same. Basics are like you have to connect P to positive, N to negative, then it is forward bias. If P is negative, N is positive, then it is reverse bias. You have to uh, go with the basic concepts of the diode configuration. Now you can see this particular circuit, figure 2.21. You can see there is a voltage 20 volt, and there is a silicon. These two diodes are not connected in the similar configuration. One is P is positive, N is negative. But here these two diodes are connected back to back, means both the N are connected to one end and both the P are connected to the far end. So this is forward biased and this is reverse biased. So the drop will be according to the, like this diode will be on, in you can see in the figure 2.23, this diode will be on and this diode will be off. The voltage drop here will be different and the voltage drop here will be different. Now, suppose these two diodes are silicon in nature. Now, if suppose this is silicon, this is germanium, then the drop of this germanium is zero point 0.3 and drop of the silicon is zero point 0.7. So the if they are connected in both and forward bias, the total drop will be 1 volt. But these two are connected in the opposite polarity. So one is off and other is on. So depending upon these configuration or the connection in the circuit, your circuit performs the operation according to the connection of the diode. This is it. So now look at this one more circuit. There is a voltage and there is a resistance. This is a diode. This is on. So there is some resistance of the diode, and hence there is one more resistance and there is one more voltage of opposite polarity. So with the current law, you will start from the higher voltage, 10 volt. You will move from this direction to this 10 volt to 5 volt. Again, this will be resistance. This is the drop of the across the diode, which is zero point 0.7. Then again, so you will follow the Kirchhoff current law, and you will follow the Kirchhoff current law to understand the operation of the diode, uh, understand the operation of the circuit while diodes are connected as a part of the circuit. So you can try to figure out with these two diagrams that how the current flows in this circuit when the diodes are connected into the circuit. If it is positive bias, then it will act as a short circuit. If it is reverse bias, then it will act as a open circuit. These are the basics of the diode. Now, parallel and series configuration. I already told you series configuration, series parallel configuration, parallel and series configuration. So according to that, like you can see from this particular figure 2.28, there is a voltage, there is a resistance 0.33 kilo ohm. Now there is a diode D1 and there is a diode D2. D1 and D2 both are connected in parallel. So their voltage drop 0.7%, and you know that in series the voltage get summed up, and in parallel the voltage remains the same. So if V1 is equals to, this is V1, this is V2, both are zero point 0.7. So the total voltage drop across this output will be zero point 0.7 only. And these are the basics of the circuit that you can easily understand while performing the operation of this particular circuit. Whenever there is a resistance, there is a drop. Whenever there is a voltage, there is a drop. Whenever there is a reverse bias diode, there will be no current flow in the circuit, and it will act as a open circuit. These are the concepts that you need to understand while performing the operations of the circuit, whether it is connected in series, parallel series, or series parallel. So these are the things, like you can see one more configuration. These two both are connected in parallel. These two LEDs, I already told you in the previous discussion that LEDs are of different color. So these two LEDs are connected in parallel. So one is red and one other is green. And both the supply are connected with the 8-volt power supply. So these two are supplies are connected simultaneously. So these two both LEDs will glow at the same time because these are connected in parallel. If suppose these are connected in series, then the first LED will glow first, the second LED will glow second, and the vice versa. So let me check out one more circuit for you. You can see these two diodes are connected in series, D1 and D2. D1 is connected in series with the D2, but however, these are connected, both are connected in the forward bias. And if you remember the previous circuit I just told you in this particular video, in that circuit, the diodes are connected. One is in forward bias and the other is in reverse bias. But here you can see in the figure 2.37, these two diodes are connected both in forward bias. That's why their operation will be different from the previous circuit. And the analysis you can see in this particular circuit, that is a figure 2.38. So if you are a student of electronics, whether you are in first year, second year, third year, or final year, you can easily understand the operation of the circuit. If you are in first year, you will be brushing up the basics of the KCL, KVL, laws of electronics, and laws of electrical. So with these laws, you can understand what I'm trying to say or what I'm trying to deliver to you. Give me 1 second. Let me connect the charger. Okay. So now, moving on our discussion. Hmm. So, and you can see this, the calculation are performed with the Kirchhoff current law and the Kirchhoff voltage law. So you can easily. Now coming on to the topic of the logic gates. You know that there are several kind of gates are available. Basically, there are three gates: AND, OR, and NOT. However, universal gate are and NAND and NOR, and there are two more gates: XOR and XNOR. So all these gates are realized um, using the diodes. As you can see, there is a power. You can see the figure 2.39. There is a supply 10 volt. If 10 volt is supplied, this will be on, and you will get the output as on. If this is working as a positive or logic, or means if both the supplies are on, you will get the output. If one of the supply is on, you will get the output. If both the supplies are off, then you will not get the output. So you can see you will get the output when this is 10 volt. You will get the output when this is 0 volt, because you will be getting the output from the first diode. So in all the three cases, you will get the output from this particular circuit. However, if both the supplies are off, like E is 0, E1 is 0, and E2 is 0, then you will get the output at the 0. So this particular circuit is acting as a positive logic OR gate. So if you try to understand the operation of this particular circuit, then you can understand or realize that all the logic gates, whether it is on, AND, OR, and NOT, can be realized using the silicon diode or the germanium diode. If you're using silicon diode, the drop will be higher, 0.7. If you're using the germanium diode, the drop will be less. It will be 0.3. So you can see the operation of this particular circuit. This is D1, this is D2, and you can see this operation, how they are connecting with the Kirchhoff current law and the Kirchhoff voltage law. So these are the circuit that can be realized very easily. And this is the circuit and the positive logic AND gate. Figure 2.42 is acting as a positive logic AND gate. Now you can see if this is E1 is equals to 10 and E2 is equals to 0. Suppose E1 is equals to 10 and this will be reverse bias, so this will be off. And E2 is equals to 0 and this will be forward biased, and you will get the output at 0. So if one is on, you will getting, and the other is off, you're getting the output as 0. Okay. So and if suppose 1 0, so and 0 0 is 0, and 1 1 is 1, and 0 1 is 1, and 1 0 is 1. In the 1 0 is 0, 0 0 is 0, 0 1 is 0 in the AND gate. Only the 1 1 is 1 1 is equals to 1 in the AND gate. So this circuit is acting as a positive logic AND gate. So moving on to the discussion, there are kind of a rectifier. However, the rectifier I will discuss in the next video, but let me try to give you some basics of the rectifier uh, so that we can continue our discussion in the next video. Basically, there are two kind of rectifier. One is the half rectifier and other is a full wave rectifier. The half wave rectifier only rectified the half pulse. However, the full wave rectifier rectify the full wave pulse. But half wave rectifier have the less efficiency, and there is more AC content available in the half wave rectifier. Whereas in the full wave rectifier, there are less AC content, and both the cycles, both the positive and negative cycles, get rectified in the full wave rectifier. And the full wave rectifier are of two types, center tape and the bridge rectifier. The details of the discussion we will discuss in the next video. Until we are, I'm really happy that you have watched the video. And if you have any comments or suggestion, do post them, and I will be really happy to answer your questions and the suggestions. Thank you.